All right, so I do my sine and cosine graphs using a couple of little tricks along the way. Hopefully these might help you get through it. The first thing in my head is I straight away work out what type of graph is it. Is it sine or cosine? This is a sine graph, so it's going to start at 0, 0, goes up and down from there. That's a very bad graph, but you get the idea. It's kind of this starting point that I wanted to focus on. The second thing I look at is what is the amplitude of the graph? How far up, how far down will it go? So the amplitude's like the size of the wave, how far up and how far down. And the number in front of the sine or cosine is always the amplitude. So I know that the amplitude equals 2, and I write that down to help me. Second thing I look at is the period. So the period is how often the wave repeats itself. So the amplitude, how big is the wave, period, how often before the wave repeats itself. So the wave's going to repeat itself when I get back to this point here. And there's a formula for the period. The formula for the period of a sine or cosine graph is 2 pi divided by n. And the n value is always the multiple of the variable, or the multiple of x. In this case, what am I multiplying x by in here in the brackets? 1. Good. Let's write the 1 in there. So my period equals 2 pi on 1, which just equals 2 pi. So I know that my graph is going to repeat itself after 2 pi radians. Okay, so the period, our graph's going to repeat itself after 2 pi. My couple of tricks here. First thing comes back to, remember, drawing the sine graph is just drawing how far, or the height on the unit circle for each angle. So how far up my unit circle goes. And my unit circle has got 1, 2, 3, 4 quadrants. A sine graph has 1, 2, 3, 4 parts because of those 4 quadrants. Okay, we've got the part where it's getting bigger, then getting smaller, but still positive, and then it is negative and getting more negative, and then it's increasing back to 0 again. Getting bigger, getting smaller, more negative, back to 0 again. So I use this to help me create my scale for my axes when I'm drawing my graph. So, amplitude, period. The third thing that I always do to help me is I create the scale. And to create the scale, I'm just going to do the period multiplied by 1/4. You can divide it by 4, but multiplying by a quarter becomes easier when we've got fractional periods. So I'm going to do 2 pi multiplied by 1/4, which equals 2 pi on 4, which equals 1 pi on 2. Okay, this is just the scale. You'll never get a mark for this in an exam. It's just going to help me draw a good graph. Okay, so now I move to drawing my nice graph. Axes. This is sine or 2 sine x that I'm going to draw. And this is my x value. These are my angles. This scale value I'm going to use to make my little markers on my x scale. So my first point is going to be pi over 2. My second point is going to be 2 pi over 2. My third point, have a guess, 3 pi on 2. Fourth point, 4 pi on 2. What's 4 pi on 2 the same as? 2 pi. So I can get my scale on there really quickly and easily. Then I can do some simplifying. And what I have created is a scale for each of my parts of the sine graph, and my graph scale now goes between 0 and 2 pi as specified by the question. So, specified in the question. The amplitude it'll go up to 2. What will it go down to? -2. That's not rocket science, that's pretty straightforward. Okay, then a sine graph has 4 parts. So this is where my 4 parts, my unit circle, come in. So I've got the part where it's increasing. I use my scale and my points. This is the part where it's increasing. Then it hits its maximum value and it starts decreasing back to 0. I use my scale to create the part where it's decreasing back to 0. Then it's getting more negative until it hits the most negative value. In this case, the most negative value is -2. And my whiteboard marker is a little bit squeaky. And then increasing from the most negative value back to 0. And because it's got a set domain, I need to label those endpoints with their coordinates. And I should also probably label the x-axis with its coordinates. If the question doesn't say label with coordinates, you don't have to waste time putting coordinates on there. But in exams, they will often say label important features with their coordinates. And if you don't write it in brackets as a coordinate, you lose a mark. What have I forgotten? The -1. What does a -1 do when we stick it on the end of the equation? Moves the whole thing down one place. All right. So now we've got to move my whole graph down one place. Will that change my scale? No, it will not. Still pi on 2, 2 pi on 2, which is pi, 3 pi on 2, and 4 pi on 2, which is 2 pi. I'm going to do another little trick. I'm pretty sure the video showed this as well. I'm actually going to draw kind of like that midpoint line, that average line, that center line. So it can help me draw my graph with my scale. This is going to be at -1 because my whole graph has been moved down 1. So what was on the axis has been moved down 1. Again, never get marks for this. If you draw it on an exam, I would recommend that you draw it in pencil and then rub it out. If you haven't got time to rub it out, leave it there, but it's not part of the graph. It's not an asymptote that we've seen in other graphs. What will my maximum now be? 1. What will my minimum now be? -3. So let's try and get a scale that's roughly appropriate here. -3. My graph now starts at this midpoint. That was on the axis. I called it a midpoint. I don't know why, but that'll do. So that starts now at 0, -1. And it'll go up to 1 pi on 2. Then the next point on the scale comes back to that center line. Next point on the scale down to -3, and next point on the scale back up to that center line. If we're labeling all important features, what else do we need to find? What else do we need to find? The axis intercepts. So what we're going to move to now is how do we actually find those axis intercepts? Okay, so this is the second part of the example. This is the part where we find the x and y axis intercepts. So just before I start, let's remember, how do I find an x-axis intercept? X-axis intercept is when we let y equal 0, exactly. So we're going to substitute y equals 0 into our equation. So that's our problem. The problem that we're trying to find or solve is 0 equals 2 sine of x minus 1. That's our problem. You can do this on your little slip that we'll hand it out to you. Yes. What's the domain that we're solving our problem over? So we're going from 0 to 2 pi. And they're included in this question because we're told to graph between those 2 points. First thing, I'm now going to start solving the equation. So when I start solving this equation, my normal step is that I just rearrange. So I'm going to do exactly that. I'm going to rearrange this equation. I'm going to start by adding 1 to both sides. Like that. My texters aren't great today. And then I'm going to do the opposite of multiplying by 2, which is dividing by 2. So the question that I'm trying to now solve is when is sine of x equal to 1/2? Okay, so when is sine of x equal to 1/2? When is sine of x equal to 1/2? All right, so to get that, we're going to go straight to our exact values table. We have an exact values table that tells us the angles when sine is equal to 1/2. What is that reference angle from the exact values table? When is sine 1/2? And tell me in radians, not degrees. It is pi on 6. Excellent. So my reference angle that I'm going to work with is equal to pi on 6. Okay, we're going to work with this pi on 6 now to find my other values. We know from our graph, we can see from our graph just before, that we've got 2 x-axis intercepts. This is not necessarily going to be my answer. It is not necessarily going to be my only answer. So the next step that I take, I'm actually going to work out where are my first and second solutions in the unit circle. When will sine be equal to 1/2 in the unit circle? So remember, sine is the vertical height, and it will be 1/2 roughly there. So those 2 angles would be here and over on this side. Okay, we're trying to find out what are my 2 angles. There's my first angle, there is my second angle. Right, so that pi on 6, what has that got to do with my unit circle that I've just put here? It's equal to 30 degrees. This is my first angle, which is pi on 6. So this is my first solution. Then what's my other angle over here that also gives sine equal to 1/2? It's 5 pi on 6. So this is my second solution. Now in this case, I don't have to finish the solve. These are my 2 solutions. I don't have to do anything extra. So one option is x equals pi on 6. The other option is x equals 5 pi on 6. That's my first and second solution. What we do in the other parts here is when we have different domains. So if we have a larger domain and if I have to search for extra intercepts, or if there was a dilation factor and it was squashed up a little bit and we had more repeated x-axis intercepts and I had to find extra solutions, then we can use these other 2 parts. I'll show you that in another question that's coming up. Okay, we've got my 2 x-axis intercepts. I'm going to check when I put it on my graph, which won't be on the camera, but if we actually look at our graph, I'm saying the first solution is pi on 6. Does that seem logical based on what we put on here? That's 90 degrees, that's 30 degrees, seems about right. Thank you, Alice, that's awesome. This angle over here, we're saying is 5 pi on 6. So if that's 5 pi on 6, does that make sense with what we're seeing on our scale? 5 pi on 6 is a little bit less than pi. Yep, makes sense. I've got no other x-axis intercepts to find. We're done. We're finished. Thank you. You can stop it. Okay, so we're looking to solve this equation. We've got cos of x plus root 3, and I probably should specify that there's brackets just go around that part. So it's cos of x plus root 3 equals negative cos x. We're going to solve this over the domain from negative 2 pi to 2 pi. First thing that we always try and do is we want to start solving it. We want to get our bits together and see what's going on and try and create the most simplified trigonometric equation that we can solve. So the way I'm going to start this problem is I'm going to add cos x to both sides. All right, so pretty straightforward. We're going to get, when I add cos x to this side, I'm going to have 2 cos x plus root 3 equals 0. The next step, I'm going to subtract root 3 from both sides, which gives me 2 cos of x equals negative root 3, and then divide both sides by 2. Cos x equals negative root 3 over 2. Okay, so we've got our simplified equation where it's basically just cos x equals negative root 3 on 2. Next step, we're going to find that reference angle. Where do we get the reference angle from? We get it from our exact value table. All right, so you look up your exact values table, and I don't have a negative in my exact values table, but I do have a root 3 on 2. So when is cos equal to root 3 on 2? What angle gives me root 3 on 2? Pi on 6. Right. So my reference angle is pi on 6. I know that I have something to do with pi on 6s here. It has to be symmetrical with pi on 6. So on this side, what my brain is doing right now, I'm saying, well, where are all of the angles that are symmetrical with pi on 6 in the unit circle? I've got pi on 6, that's here. I've got another one over here in the second quadrant, that's 5 pi on 6. I've got another one here in the third quadrant, that's 7 pi on 6. And another one in the fourth quadrant, which is, what are we up to? 11 pi on 6. I could also go around the unit circle the opposite direction, and this could be minus pi on 6, minus 5 pi on 6. And I'm going to talk a little bit more about this as we go around. Okay, once I've got the reference angle, the next step, I'm going to work out, well, where are my actual solutions that I want? Which one of these am I actually working with based on that question? Now, notice, this question is telling me that cos is negative. So we want the angles that relate to pi on 6 that give me a negative cos value. Where are those two angles? They are on the left side. So this will give me a negative cos value, and this one here will give me a negative cos value. So my first solution would be the 5 pi on 6 solution, and my second solution would be the 7 pi on 6 solution. So x equals 5 pi on 6, x equals 7 pi on 6. Okay, here's where my hacks come in. I'm going to go back to this original question back up here, and I'm going to think about, this is a cos graph. What is the cos graph? Basic cos graph. What would the period of this cos graph be? The period would be 2 pi divided by n, which would be 2 pi divided by 1, which just equals 2 pi. Correct? So if this was a cos graph, that graph would have a period of 2 pi on n, which would have a period of 2 pi on 1, which has a period of 2 pi. I'm going to write that period as having the same denominator as my solutions over here. And because I shrunk this, I didn't fit it in the box quite correctly. How can I write 2 pi to have the same denominator as my first two solutions? I'd write it as 12 pi on 6. So that period is equal to 12 pi on 6. I just multiplied the numerator and the denominator by 6. Okay, so this is my first hack. This is going to help me find my other solutions. Second hack, I'm going to write my domain to have the same denominator as what I had over here. So my domain was negative 2 pi to 2 pi. That was the question. If I write that to have the same denominator, it would be negative 12 pi on 6 to 12 pi on 6. All right. Final step. I have found two solutions. We don't yet know if they are the only solutions. There could be more, because we know that our sine and cosine graphs go like this. So if we're looking for a solution to the equation, there could be many, many different answers, both positive and negative. All of these points would be like all of my solutions. There are multiple solutions in sine and cosine graphs. So we have to check, have we found all of the solutions in this domain? And the way that we do that is really simple. It uses these hacks. Because the unit circle is a cycle, the next solution will come when I've gone one lap around the unit circle back to this point. Okay, so my next solution will occur in the same spot. It will occur after I've gone one cycle around the unit circle. So I'm going to start with my first solution, 5 pi on 6, and I'm going to add the period, 12 pi on 6. That gives me 17 pi over 6. Now, is this answer still in my domain? No? Too big? So, doesn't work. It's not a solution. So if I go forwards around the unit circle, if I make my angle bigger, my next solution is outside the domain. What do you predict I might do next to test? Go the other way. How do I go the other way around the unit circle? I subtract instead. So now I'm going to start with my first solution and I'm going to subtract the period. 5 pi on 6 minus 12 pi on 6 is minus 7 pi over 6. Is this answer within my domain? Yes, it is. So this is another possible solution. Okay, try the other angle. We had 7 pi on 6 minus the period. 12 pi on 6 gives me minus 5 pi on 6. Is this within my domain? So it's a possible solution.